Hello friends, hope you are having a fantastic day today. So the lead code problem we are going to solve now has to be one of the most difficult problems that I have solved so far. It's called burst balloons. We can see that this one is a lead code hard problem and very justifiably also a very well-liked problem. So basically we are given n balloons that are under index from 0 to n minus 1. So they can be placed in an array. Now for each balloon is painted with a number on it. That number is represented in an array called nums, and we are being asked to burst all of these balloons. Now the number that is currently written on that particular balloon represents like some sort of coin values. But the thing is, when we burst a balloon, we actually get coins in by multiplying its neighboring cells with that particular number. And then neighbors basically change because we already burst a balloon from in between, and then we keep on repeating the same process. Our aim is to make sure that we can receive maximum number of coins by bursting as many balloons wisely. So this is the key phrase. Now we are being told that let's say that we run into an issue where there is a neighboring cell that is at the edge of the given nums array. Then basically just imagine that there is one neighboring cell with one painted on it, so that we don't run into an issue of array being out of bounds. So let's say that we are given an example of two balloons. The values are 1 and 5. Now notice for these two balloons, basically we can treat them as following, where the middle two balloons are still going to be values 1 and 5 as represented over here, but it is going to have two neighboring balloons that are valued 1 and 1 that we are not going to burst. We will only consider these two balloons, but they are there for us to our support. Now what is the maximum value we can achieve? Now let's say that we decide to pop balloon number 5. If we pop balloon number 5, basically we get value such as multiplication of its neighboring values. So it would be 1 multiplied by 5 multiplied by 1 because of these three values. Now notice this would yield us the result 5. Plus we still have one more balloon because we already popped balloon number 5. We would have one more balloon 1 that needs to be popped, and now its neighboring cells would become 1 and 1 and with 1. So this would become 1 and this would total out to 6. But thing is, this is not a wise approach. Why? Because in the same example, if we notice that instead of bursting balloon number 5 at the beginning, if we decide to burst balloon number 1 in the beginning instead, then basically our values would be, so we burst this balloon number 1, so that would yield us the value of 5 multiplied by 1 multiplied by 1, so total would be 5. Plus now this balloon no longer exists, but we still have this 5 left, and its neighboring balloons are 1 and 1, so this is also going to be 5 plus 5, so total is going to be 10, so we need to return 10 in the answer. Let's say same way we are given the values 3, 1, 5, 8. Now in once again for this example as well, we can choose wisely, and the most logical way to pop balloons would be that if we decide to pop balloon number 1, we would get values 3 multiplied by 1 multiplied by 5, and the remaining balloon would be 3, 5 and 8. Okay, so let's sum up this value. So this is going to be 15. So 15 plus these three values. Now once again in this case, and remember, imagine that there are going to be two neighboring ones present at all the times. Okay, now once again we would decide to pop balloon number 5. If we do that, we will be doing 3 multiplied by 5 multiplied by 8, and the remaining balloon is going to be value 1, 3, 8 and 1. Okay, now once again in this case, this is going to be 15 plus this is going to be 120 plus this is, now in this case the ideal thing would be to pop balloon number 3. If we pop balloon number 3, then we get value 1 multiplied by 3 multiplied by 8, so 24, and then we would no longer have 3 existing, so last value would be 8 remaining with 2 adjacent ones, and that would be plus 8. And if we do total of all of these values, the maximum number we can achieve is going to be 167, and this is what we need to return in the answer. So I hope this long explanation makes sense that what is being asked for us to solve this problem. Now, very first approach comes to our mind is a typical brute force approach, that if we are given n number of inputs, let's say values 1, 2, 3, 4, right? Why don't at every given position we have the 3 option of choosing whether to pop that balloon or not to pop that balloon. So if we decide to pop balloon number 1, then we are going to be left with the value that we received from balloon number 1. So that is going, let's say that the value is x, plus we have the possibility of dealing with the remaining 2, 3 and 4 values. And once again in this path, once again we will have the option to take this x, plus amongst 2, 3 and 4 we can pick a number. So let's say we decide to pick balloon number 2, so that value becomes y, and then once again we are going to be left with values 3 and 4, and once again we will be making a decision. Same way for every single value we can make a decision based on the sequence of balloon we pop, and same way we are going to have different choices, and subsequently it will grow over period to basically all of the different permutations and combination of choices we can make. So that is going to be a very huge decision tree that we can make. Now in this case the answer is going to be 2 to the power of n, where n is the total number of characters present, because at every single instance we are deciding whether to include that or not to include that. So that's a very expensive time complexity. That doesn't work. Let's try to become greedy in our approach. So greedy approach works something like that. Basically we can take an input and we will try to pick the smallest value. So let's say that we saw in the example of 3158 that we would pick the 1 first because it was the smallest value, so it would not bring any like long-term benefits to us if we just keep it around. So why don't we burst balloons with the smallest value possible? So in that case, if we decided to burst this balloon number 1, let's say being greedy, okay, so we get the value as 15, okay, plus now we are left with three values, 3, 5 and 8. Once again logically we would be bursting balloon number 3. So if we do that, once again we would be generating the value as 3 multiplied by 5 multiplied by 1. So this would become 15. Plus same way we would be left with value 5 and 8. If we do that, we will be bursting value number 5, so the value would be 40, and plus lastly there would be value number 8, so this would become 8. So if we do sum of all of this, it's going to be 30 plus 40, 70 plus 8, 78. So greedy approach also doesn't work, because we know that if we can do it wisely, we can solve this problem and gain 167 coins amongst this input. So this is also a second choice that would not work. So now the solution would become pretty obvious to you. So in this case, we are actually going to be using the most powerful and beautiful concept of the entire computer science, and that is called dynamic programming. Now, how we are going to be using dynamic programming is that, remember in the brute force approach, basically when we had 4 inputs, we would take certain paths. So we would pick what if we burst balloon number A, and then we are left with whatever the value we generated from balloon number A plus whatever value we can generate from B, C, D. Same way, once again we have two choices of A plus B plus whatever value we generated from CD. Same way over here we could have decided to burst balloon number balloon number B, and then once again generate the value that would be gained from A, C and D. And once again we could have burst balloon number A, and then once again the values would have been C and D. Now notice that both in this case we are left with value A plus B plus CD and A plus B plus A plus CD, basically in just reverse sequence. So we need to keep track that at every given moment, whatever the balloon we burst, depending on whatever the range, what is the value we are generating. Now important phrase over here is going to be range, that we need to know that between every single combination of values, what maximum coins that we are able to generate. Now in this case we'll need to do we'll require a 2 by 2 matrix. Now notice in 2 by 2 matrix I'm using the same example we used 3158, but we have added one at each of the end. They are just denoted by different color, and they are to make sure that we have a neighboring cells present, but we are always going to be iterating amongst these 4 values. Okay, so when I talk about keep track of the values of bursting balloons, that would be amongst this set of values. Now one more thing is, let's say that I only give you value number 3 and ask you that what is the maximum balloon I can generate. You must be saying that hey, it's pretty straightforward. We would do like 1 multiplied by 3 multiplied by 1, and total is going to be 3 for sure. Now let's say that I give you value 3 and 5. Now what is the maximum possibility? Well, we have two possibilities. One possibility is that we actually take 3 first, so basically that would become 15 plus 5, or we could have taken 5 first and that would have become 15 plus 3, so greater total is 20. So we can say for a fact that if we are dealing with only two balloons with value 3 and 5, maximum value we can generate is going to be 20. Now in this case, let's say that we add one more possibility, that 3, 5 and 8. Now for this fact, we can say for with certainty that with this 8, the maximum value amongst this 3 and 5 we can generate is going to be 20. So we can leverage that fact and we can use it to our advantage. In this case, there is also possibility that instead of taking 8 at last, we can take 8 somewhere in middle. So we'll need to keep track that what would be the value being generated with the value 3 and 8, and we'll have to keep track of all of these different permutations and combinations of values. So that's why we need a 2D matrix and a sequence of range that we are going to be determining. Now in this case, let's just try to do it one by one, starting with the smallest range possible, and that is going to be of interval 1. So let's say if we are only dealing with interval 1 ranges, what are the different values that we are trying to compute for? First value would be 1 1, second value would be 2 2, third value would be 3 3, and fourth value would be 4 4. Okay, now for 1 1 we are thinking that if for 1 1, if this were to last value that we are going to be bursting, what is going to be the result? So basically because range is 1, remember, so we are only incrementing the neighboring cell by 1. So in this case, 3 multiplied by 1 multiplied by 1, so the maximum value we can generate is going to be 3, so we will mark it over here. Same way in this case, let's say that for some reason we decide that instead for 2 2, so for 2 2, this is the value that we are talking about. What is going to be the maximum value we can generate? The neighboring cell, so remember that we have decided that we have burst all the neighbors in that range, but because this range does not have any value other than that, these are going to be the neighbors. So this is going to be 3 multiplied by 1 multiplied by 3, so that is going to be 15, so we can mark 15 as it is. Same way for value number 5, once again there are no neighbors, so 1 multiplied by 5 multiplied by 8, so that is going to be 40. And same way for value number 8, once again 5 multiplied by 8 multiplied by 1, so that is going to be 40. So we can mark all of these values as it is. That's cool. Now let's up the ante and let's update our total number of range that we are currently trying to build out. So first range would be of size 2. Now comes the interesting part. Now what are the ranges we can generate? So range would be 1 to 2, second range would be 2 to 3, and third range would be 3 to 4. Now let's talk about just range 1 to 2 for a moment. Now in the range 1 to 2, we are talking about basically these two values 3 and 1. Okay, now 3 and 1 amongst the grand scheme of total 3 1 5 and 8 amongst these four values. So now notice that we have the two choices. First choice is that 3 would be the balloon that we would pop last, or 1 would be the balloon that we would pop last. What if we decide that 3 would be the balloon that we are going to be bursting last? Then in that case, what is going to be the neighbor of 3 that we would multiply 3 with? Because we have already popped 1, so that would be value number 5. So that would be 1 multiplied by 3 multiplied by 5. This 1 we got from the neighboring 1, that is this over here, and 5 we got, that is the end of the range, that is the over here, plus we must have received whatever compensation we got by bursting just balloon number 1, and that is going to be dp of basically 2 and 2. So this is that is this value. So the maximum value we can generate is 15. So in this case, it's going to be 15 plus 15, so maximum value we can get is 20 for range 1 to 2 by bursting balloon number 3 last. So one possible value is 20, so let's just mark 20 as it is right now. Let's just come back once again, do our calculation. Now for the same scenario, we are considering that what if we decide to burst balloon number 1 last. So okay, so 3 and 1, we are bursting this balloon number 1 last, which means we have already burst this balloon. So what is going to be the neighboring cell? 1 and 1 and 5. Now what is going to be the value? So bursting balloon number 3 would give us maximum value of 3. So let's mark 3 plus bursting this balloon number 1 now would be 5 multiplied by 1 multiplied by 1. So that is going to be 8. So 5 and 8, yeah, so basically 5 plus 3. So total is going to be 8. So in this case, because the higher value is going to be the maximum value that we can generate, that would be amongst this, oh sorry, this value was supposed to be 30 not 20, because remember we did 15 plus 15. Okay, so now the maximum coins that we can generate at between range 1 to 2 would be amongst the maximum between 30 and 8, and we know that maximum value is going to be 30, so we will just mark 30 over here. This defines that this is the maximum number of coins we can generate for this particular range. Now let's just come to the next range in our set of sequence, and now I'll just start moving quickly because I don't want to spend this much time for each of the things. Okay, next range would be value 2 to 3. So now 2 to 3, the values are going to be 1 and 5. Okay, now for this one, what if we decide to burst balloon number 1 first, sorry, balloon number 1 last? If we burst balloon number 1 last, basically it's going to be value number 3 multiplied by 1 multiplied by 8. So that is going to be 3 multiplied by 1 multiplied by 8. So that would be 24 plus whatever the value we get from DP at value 5 and 5, sorry, value 3 and 3. So that is value 3 and 3 is going to be 40. So the sum is going to be 64. Okay, now what if we decide to burst balloon number 5 at last? So in that case, well, it's going to be 5 multiplied by 8 multiplied by once again 3. So plus whatever value we get by bursting this balloon, so that is going to be 15. So the total is going to be 135. So logically it makes sense that at range 2 to 3, the maximum value we are able to generate would be value 135. So we will just mark 135 as it is. Okay, now the last range we have is going to be range 3 to 4. Now once again, at the values range 3 to 4, what are the basically two balloons that we are able to pop? The values are 5 and 8. So we can either pop value number 5 in the last. If we decide to pop value number 5 in the last, basically we would be gaining the value 45. If we decide to burst value number 8 in the last, we would be gaining the value 48. Now why did we get 48? I'll just quickly explain. Basically we are doing 1 multiplied by 8 multiplied by 1. So this is 1 and this is the second one, because remember we are talking about this range, and plus whatever value we get by bursting this balloon, so that would be 40. So basically 8 plus 40, so that sums up to 48. Okay, so maximum value is going to be 48 between the range 3 to 4. So we'll just mark it over here as 48. Okay, now same way, now we took care of all the intervals of size 2. What about all the intervals of size 3? So once again, for this one, the complication now becomes even more critical, because now the first range we are talking about would be 1 to 3. So we have the 3 candidates. 1 2 3 would be 1 2 and 3. So now we have 3 candidates, basically 3 1 and 5, to solve this answer. And for each of the one, so we have, what if we decide to go each of the one in the end? So I'll just do calculation for one of the values, for value number 3. So basically this would, what if we decide to go with this value at last? Now remember, 3 would be multiplied by 8 and it would be multiplied by 1. So it would be 1 multiplied by 3 multiplied by 8, because we took care of the entire range. Okay, plus now because this is the first value in the range that we are talking about, we would also need to do the dynamic programming of range between this value 2 and 3. So 2 and 3, we already have the answer, and that is 135. So this would become 135 plus 24. So the total is going to be 159. Okay, now what if we decide to burst balloon number 1 in the end? Once again, that value is going to be 51. And what if we decide to burst balloon number 5 in the end? The value is going to be 70. So 159 is the obvious choice. So between the ranges 1 to 3, the maximum value we can generate is going to be 159. So we'll just mark 159 as it is. Same way for the range 2 to 4, the maximum value that we are able to generate would be once again value 159 as well by the same logic. And so we'll just from 2 to 4 the value would be 159 as well, so we'll just mark it as it is over here. And now comes our final range, that is of range size 4. And for the range size 4, the only possibility in this case we are going to have would be basically just one value. So the range would be from 1 to 4. We have the possibility of bursting 3, 1, 5 and 8, all 4 balloons at the last. What if we decide to burst balloon number 3 last? If we decide to burst balloon number 3 last, basically the coins we would be generating would be 3 plus whatever the range we can get. So basically 2, 3 and 4. So dp of 2 to 4. So dp of 2 to 4 we already know that value is 159 and plus value number 3. So that is going to become value 162. Okay. Now let's do the calculation for value number 1. So basically once again for value number 1 the total would be 159 plus the total sum would be for value number 1 the total would be only 52. And why it would be 52? Because remember this value the range would be so for this one value number 1 the range would be basically we would do multiplication. So that is 1 multiplied by 1 multiplied by 1, so that would be 1 plus, remember we have two ranges. First range is dp of 1 to 2, so dp of 1 to 2, and second range would be dp of 2 to 4, and dp of 3 to 4 because we already took care of dp of 2. So this dp of 1 to 2 is going to be 30 plus dp of 3 to 4 is going to be 48. So 48 plus 30 plus 1, so whatever the value that would come up to. So on and so forth. If we keep on doing, basically the maximum value we are going to be getting would be for value number 8, because remember for value number 8 the multiplication would have been 8. Okay, let me just clean this up a bit, and I know that this video is getting super longer, but it is what it is. Okay, for value number 8 basically the multiplication is going to be 1 multiplied by 8 multiplied by 1 by ignoring all of these values, plus dp of range 1 to 3. So range 1 to 3 the value is 159. So 159 plus 8, so this would become 167 that we would store over here, and this is what we are looking for, that what is the maximum value we can generate between range 1 to 4. That would be 167, so we can return that as the answer. I know this was a super long video, perhaps the longest one that I did for dynamic programming, but it's an important one. Now let's analyze the time complexity. We'll have to iterate over n by n matrix basically, so that would become big of n square work, and for each of the ranges we will have to do it, so that would be multiplied by n, so that total time complexity would be big of n cube. There is no other way to do it faster than this, even with using the dynamic programming. And space complexity is going to be big O of n square, so which is a reasonably good time complexity given how complex this problem is. So now let's quickly see the coding solution for this one. Now the coding solution is slightly straightforward. So basically we are given total length n. Based on that we are going to be generating our extended array that is going to be of size n plus 2, and we are going to be adding the last values as 1, that is to take care of the neighbors. Then we are going to be iterating over the original nums array and add values to our extended nums array, that would be for simplicity for us to update all of the values. Now we will generate our dynamic programming array, that is, notice that the values is n plus 2 and n plus 2, that is to take care of the two neighboring cells. Now we'll start filling in our dynamic programming table and iterating over all the values. On top of it, we'll have to define a range for every single different position, and that is what this right length defines, that this is the range we are talking about. And at every given range, for every single range that is possible, we will calculate that what is the maximum coin we can achieve on that particular value. That would be by doing the multiplication of extended nums left minus 1 multiplied by extended nums of that particular value multiplied by extended nums right plus 1. Notice that we are taking the values that would be out of the range for every single value, and we are updating the value plus by doing the coins of dynamically programmed ranges that we have already found so far. So for any ith range, the value would be dp of left to I minus 1 plus dp of I plus 1 to the right, and we already have the values being calculated by bursting that particular balloon. And the range value at any particular location would be the maximum value that we currently have, or the new maximum value that we just found. Whatever is greater, we'll just store it in the result. So these are the 3 for loops that would take care of all the entire logic that we just explained, and then we can simply return the value for the range 1 to n, that is the range that we are given in the input. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code beats nearly 80%, like 74% of all the other solutions, which is pretty awesome. I would be posting this in the comments and in our GitHub repository, so feel free to go and check it out from there. Thank you.